Hello, statisticians. Mr. Youngsaver here from Skew the Script. The vast majority of the scientific community says that climate change is real and that it's caused by humans. But some people look at the same data and say that their conclusions are invalid. So today we're going to explore this debate by looking at some climate data ourselves using a match paired t-test and a match paired t-interval. Let's skew it. Today's lesson is on inference for matched pairs. This is lesson 8.5 in our course sequence. About 97% of climate scientists with PhDs say that current climate change is real and caused by humans. But only about 50 to 70% of Americans say the same thing. And this is based on survey data of citizens. One doubter of the climate science is Michael Crichton. And he wrote a very prominent book among climate skepticism circles called State of Fear. The plot of this book is that eco-terrorists are plotting mass murder for the sake of propping up their false theory of global warming. And even though the book is fiction and is framed as fiction, it has tons of graphs of real data, footnotes to scientific articles, and a 20-page bibliography. The author, Michael Crichton, is a science fiction writer. He wrote Jurassic Park, created the TV series ER, and he did earn a medical doctorate, but didn't end up pursuing medicine in his career. So who should we trust here when talking about this issue? 97% of climate scientists, or the 3% of climate scientists who don't say climate change is real and caused by humans, and folks like Michael Crichton? Well, Congress invited Michael Crichton to the Environment and Public Works Senate Committee to be an invited speaker and give his testimony. Senator James Inhofe said of Crichton, "I've read most of his books. I think I've read them all. I enjoyed most State of Fear and made it required reading for this committee, the science fiction book as required reading for the Environment and Public Works Committee." And the book itself remains the most cited work in climate change skeptic literature to this day. So instead of shirking away from this, let's tackle it head on. Let's investigate. Does the data in State of Fear disprove climate change? If you'd like to follow along using a handout, you can print it up at this URL from our website. So first, we're going to talk about identifying a matched pair situations and then inference for those situations. So there's one chapter in State of Fear called Punta Arenas. Punta Arenas is a city, a small town in the very, very south part of South America, close to Antarctica. And the characters go to a weather station there. They see a graph of climate data on the wall. And one character says, "It's the record from the weather station at Punta Arenas, near here. That's the closest city to Antarctica in the world." And he tapped the charts and laughs. There's your global warming. As you can see from the chart, which is the exact chart I just screenshot from the book, the climate appears to be decreasing in temperature pretty steadily over time from 1888 to 2004. So first thing we're doing when we check data is to make sure that the source is valid. So the source is from the GISS NASA data set. And NASA maintains a set of surface temperature station data, and it's a very good source. It's one of the most prominent sources we're talking about climate data. And Punta Arenas is on the map here. If you go to the site right now, you'll see that Punta Arenas is one of the sites listed. But also note that there are 7,500 and more than that stations, not just Punta Arenas, but all over the world. So climate patterns vary a lot by location. So instead of looking at one location, let's ask, what is the average trend across many of these stations? Not just one station, but many of them. So let's look at the data for Punta Arenas first. We're going to look at the typical temperature in terms of Celsius from 1901 to 1950, the first half of the 20th century, and compare that to the typical temperature from 1951 to 2000, the second half of the 20th century. We're going to find the difference. In this case, it cooled. The temperature decreased by about 0.076 from the first half to the second half. So temperatures tend to cool down in the 1900s in Punta Arenas, and that's why the graphic looks like it did. But what about in the rest of the world? So it's very hard to get all these stations data. I would spend a lot of time on the website getting all of them. So I did a random sample of 32 pairs of longitudes and latitudes in the world, and then I found the nearest station to those pairs. So I get a random sample of stations across the world. Then I get the two temperature measurements per station, first half of the 20th century, second half of the 20th century. And then I found the differences within each station, very key, within each station. This data has a matched pairs structure. Each individual station has two measurements associated with it. And then I found the differences within each individual. So I didn't find the mean and all of them of 1901 to 1950, and then separately 1951 2000. I subtracted within each station to get a set of differences, one for each station. This is useful to do because we're controlling for variation in weather patterns between stations. We're looking at just within station differences. So here are all the temperature differences I found on a dot plot. No difference, so no change in temperature, is represented by 0. So that's where no difference is. And we can see that for the vast majority of stations, there was warming. So here's Punta Arenas' temperature difference put in context with the rest of the data from a random sample, and it's one of the only temperature cooling spots that we see. So is Punta Arenas representative of climate patterns across the world? Well, no, not according to a representative random sample. So it's clear that Michael Crichton cherry-picked this data. There were many stations to choose from, and he chose to put one of the ones that's showing cooling in his book. So in terms of this argument that his character is making in the book, it's BS, bad statistics. And if you actually look at an image of the temperature changes over time from the NASA GIS data set, we can look and see in the vast majority of places there is warming, and pretty significant warming. Where's one of the few pockets of isolated cooling where we see blue here? Right there, Punta Arenas. So obviously that was a cherry-picked data set. It's very rare to find stations with cooling. So how do we get a more representative measure of the typical change in temperature across the world? Instead of just looking at one station, looking at all that, how can we get a more representative measure of the overall change? Let's find the mean of all these differences. The mean of all these differences is 0.35 degrees Celsius. So stations on average showed warming by about 0.35 of a degree of Celsius. So let's test, is this average temperature change significantly greater than 0? Are we seeing true warming, or maybe warming by chance alone in the random sample that we have? So we're gonna do a match pairs T interval first. The cool thing about match pairs is that it's the same thing as doing one sample inference for a mean, because we're not looking at two samples here. We have one sample of differences. So we got a difference for each individual. So we're doing a single mean of the differences. And the mean of that differences was 0.35. So we're going to construct a 95% interval for the true global average difference. We need to do the 4 steps for inference: state, plan, do, conclude. So let's state the parameter we're estimating. We're estimating the true mean of the differences in station temperatures among all stations at 95% confidence. We're going to estimate this by getting a sample. Name your inference method and check conditions. We have a one sample T interval for mu D, the mean of the differences, if all conditions are met. So we got to check our conditions. The sample of 32 stations was collected randomly, so we have an unbiased center. We need to make sure our sample size is less than 1/10 of the population size. And in this case, it is, because there are 7,500 stations. 32 is way less than 10% of 7,500. And then we need to make sure our sample size is large enough to make sure that our sampling distribution is approximately normal. In this case, it is large enough. 32 is greater than 30, so we're good to go there. So we can go ahead and proceed to do our calculations. Let's perform the calculations. Again, here was the sample mean. And then if you measure the sample standard deviation, the deviation of these temperature differences is 0.269. So we can just do the same old one sample T interval that we've done before. Go to your calculator. These are the steps in TI-84. Click pause and go through them if you want. Once you do this, you get the following output. The interval is 0.24 to 0.46. So let's think about what this means in our conclusion. We are 95% confident the interval from 0.24 to 0.46 degrees Celsius captures the true average change in global temperatures from the early to the late 1900s. So we're 95% confident that there was warming, that all these positive values, there was a positive change in temperature somewhere between 0.24 and 0.46. So let's determine if we have statistically convincing evidence of true global warming on average. So for doing this, we do state, plan, do, conclude, but for the hypothesis test version, it's slightly different. In this case, you have hypotheses. The null hypothesis is that there is no difference. That is the dull hypothesis. We're trying to get evidence for the alternative, that the mean of the differences is greater than 0. There was warming. The significance level is 0.05, and then we define our parameters. And then we're going to name our inference method and check conditions. We're going to do a one sample T test for the mean of differences. And then the same conditions we checked before for the interval, so I'm not going to do them again. And then we're going to perform our calculations. In this case, here are the calculator steps for doing the hypothesis test rather than the interval. And we get a T test statistic of 6.69. and a p-value of 0.0001, very significant. So we're gonna plug this into our conclusion template for a nice, concise conclusion. Because our very small p-value is less than alpha, we reject the null. In other words, we do have convincing evidence that the true global average temperatures rose in the 1900s. So let's think about, is our interval consistent with the conclusion of our test? Well, the interval was from 0.24 to 0.46, and the test result was the alternative. We concluded that we have convincing evidence that the mean of the differences was greater than 0, i.e. temperature increase. So the results are consistent. The interval of all plausible values is entirely above 0. So we have convincing evidence of a positive change in temperature. All plausible values for that mean change in temperature are all positive. In other words, we have evidence of warming. So let's get into our discussion for today. In State of Fear, it's clear that Crichton cherry-picked Punta Arenas to show it. And a representative sample that we got using a random sample does show warming instead. So similarly, the rest of the arguments he makes in his book have been scientifically torn apart by different scientists who have read it. You can review a good discussion of that at the link below. There's also a long list of data arguments made in his book and away from his book against human-caused climate change. Among them are unreliability of ice core data, airfield sampling bias, and other things. And all these things have been debunked by scientists or have been shown to be misleading or unimportant for the overall implication of human-caused climate change currently. So we're often taught there are two sides to every story. And when you read popular media, say New York Times and newspapers, they often interview two experts on every scientific issue, or every other issue for that matter. One expert will be one side and say climate change is real and a human cause, and the other expert will be on the other side and say climate change is not real or maybe not human caused. Now, the thing here is that 97% of climate scientists agree with expert one, and only 3% would agree with expert two and folks like Michael Crichton. 97% is huge. That's consensus. Not even 97% of dentists can agree that flossing is actually helpful. In fact, it's actually kind of hilarious how much disagreement there is. Check out the link right below in the bottom here. So we're often taught, there are two sides to every story. Always talk about both sides. So I want you to think about this. Should popular media, given the asymmetry of what is believed, portray both sides of the climate change debate? What do you think? Explain your reason. That's it for today, statisticians. Have a good one.